Elon Musk didn't just launch rockets into space or reinvent electric cars. Now he wants to change the sky as we know it. The announcement of the Tesla super electric plane for 2026 already has Boeing and Airbus scratching their heads. And it's not just the futuristic design. What's at stake is a historic shift in aviation. An electric, vertical flying aircraft with 1,300 miles of range and the price of a luxury SUV, $79,597. Doesn't seem realistic, does it? But it is. Tesla will mass-produce this plane at the brand-new Giga Air in Nevada with a capacity of 12,000 units per year. And the secret? The same logic that made electric cars cheaper. Mass production and aggressive engineering. Giga Air is no ordinary factory. It uses so-called giga presses, gigantic presses that mold the entire plane's fuselage into a single piece. This cuts assembly time by 65% and reduces production costs by 55%. The method is inspired by the way the Model Y and Model 2 are being manufactured, but now applied to something much larger: airplanes. Imagine a process so efficient that it saves tens of thousands of dollars per unit simply because of the way the aluminum is pressed. And the most curious thing? This is happening in the middle of the Nevada desert, where Elon Musk is literally building a new industry from scratch. But what really took this plane from the realm of ideas to reality was the StarVolt battery. Unlike traditional lithium-ion batteries, Tesla developed an aluminum-ion version that costs just $45 per kilowatt, a surreal number, considering the industry average still hovers around $110. This alone represents a savings of over $6,500 per aircraft, just on the battery. What's more, this battery can store enough energy to fly from Los Angeles to New York without recharging. This range covers 97% of domestic routes in the US. It's the kind of breakthrough that completely changes the game. Musk's plan is not only to sell the entire plane, but also to create a shared access model called Skyshare for just $4,500 per month. Any company, flight school, or urban adventurer can share the use of the aircraft with other users. It's like an Airbnb for the skies. You pay a subscription, fly whenever you want, and share the costs with others. Analysts already predict that this model could capture 22% of the electric vertical aviation market in the US by 2030. That's no small feat. Tesla wants to democratize the sky, literally. And behind all this lies an intelligent system that seems like science fiction. The Dojo supercomputer, developed by Tesla in Palo Alto, is being used to optimize every stage of production, from aluminum cutting to logistics transportation. Using artificial intelligence, they've managed to reduce material waste by 75% and save around $18,000 per aircraft simply through more accurate demand and supply forecasts. It's almost as if the plane were assembled by an electronic brain that constantly considers cost-effectiveness. This efficiency allows the Tesla plane to sell for less than a fully equipped Ford F-150. And that changes everything. It stops being a product for millionaires and becomes a real option for businesses and everyday users. The production structure also generates 10,000 direct jobs and injects more than $1.2 billion annually into the US economy. In other words, it's a project that impacts not only the aeronautics industry, but the entire economic chain. The government wins, the workers win, and, of course, so do those who've always dreamed of flying without selling a kidney. The crazy thing is that, until recently, this was considered a crazy idea. A fast, cheap, vertical electric plane with continental range seemed like something out of a movie. But the Trump administration decided to accelerate this dream by liberalizing, through executive orders, the regulation of electric aircraft and urban testing programs. This paved the way for companies like Tesla to operate with much less bureaucracy, cutting years of waiting times and paving the way for certification in record time. When the government gives the push, and the technology is ready, the rest is history. And if there's one thing Elon Musk doesn't do, it's wait for the competition. While Boeing and Airbus are still discussing hybrid aircraft or lower-emission engines, Tesla has already put something on paper that goes further. A new type of flight, with a different logic, a different design, and a different audience. It's the birth of an unprecedented category, where flying is no longer a privilege or a luxury, it's an accessible service. And if you think all this is revolutionary, just wait until you see how Tesla has solved the biggest problem in electric aviation: battery weight. That's where StarVolt shows what it's really capable of. Weight has always been the enemy of electric aircraft. While cars can charge batteries without major consequences, airplanes need a perfect balance between power and lightness. And that's where the StarVolt comes in, as the game-changer the industry has been waiting for decades. Tesla's new aluminum-ion battery delivers 0.18 kWh per pound, an energy density 60% higher than standard lithium-ion batteries. This means more power for less weight, completely transforming the game for electric aviation. Just to give you an idea, to achieve the promised 1,300 miles of range, the StarVolt weighs just 1,984 lb, half what would be required with conventional technology. This significant weight reduction directly impacts the aircraft's structural design. With less mass to support, the plane can have a lighter, yet stronger fuselage. Tesla, in partnership with SpaceX, developed a carbon fiber-based structure inspired by the Cybertruck, which eliminates the traditional metal shell concept and adopts an exoskeleton that intelligently distributes the load. This structure saves an additional $661 kLP and ensures the plane can withstand extreme landing and maneuvering loads. It's not just about lightness. It's about structural efficiency with well-distributed weight, as if every part of the plane was designed to dance with gravity, not fight it. And it doesn't stop there. Tesla also applied the same compactness and lightweight approach to its engines. The electric thrusters used in the VTOL system were designed to be smaller, lighter, and integrated into the structure. This reduces the total load by 331 kg, further relieving stress on the landing gear. Speaking of which, the landing gear assembly was also redesigned. Using aerospace-grade titanium alloys, engineers were able to create a system that supports up to 6 times the aircraft's total weight, even with the nearly 2,000 lb battery. Each bolt was designed to withstand the pressure of a new type of flight. And the icing on the cake? StarVolt's fast recharge and discharge capability allows the aircraft to recover 18% of its energy during descent. This reduces battery strain, improves landing performance, and even contributes to its lifespan. Furthermore, because the battery is thermally stable, it doesn't require heavy cooling systems. This detail alone shaves an additional 265 vibrators from the structure. Now that's engineering down to the last detail. Less weight, more space, less fuel consumption, and greater safety, all at the same time. This weight balance allows the plane to fly like no other in its class. Tesla's onboard artificial intelligence dynamically adjusts flaps, thrusters, and wings in real time to maximize lift and reduce structural impact during flight. Imagine a plane that learns how it's being affected by gravity and wind, and automatically adjusts its aerodynamics to better respond. It's the kind of adjustment that once existed only in military fighter jets, and is now making its way into a commercial electric plane you can subscribe to by the month. And of course, energy recovery also has a direct impact on battery life. While the market estimates aviation batteries to last between 1,000 and 2,000 cycles, StarVolt delivers up to 2,500 complete cycles, and all without aggressive degradation. It's as if it's ready for a full decade of operation with stable performance, and when it's time to replace it, the system is modular. Simply replace the affected module. All this reduces maintenance costs, increases service life, and makes the aircraft a much more economically viable platform. Another notable feature is how the landing gear has also received upgrades based on reduced weight. Instead of using traditional shock absorbers, Tesla developed an intelligent absorption system inspired by SpaceX's landing gear. Yes, the same ones that support rocket landings. This technology distributes the impact precisely, reducing localized pressure by 30%. This not only protects the fuselage, but also ensures softer landings on smaller surfaces, which is essential for an urban VTOL aircraft. And if all this seems like overkill, just look at the numbers. Tesla's 1,984 LB battery offers the same range as a lithium-ion battery weighing nearly 4,000 VTOL, and with less weight comes less stress, less material required, and more design possibilities. With every bolt lightening the load and every inch of the fuselage designed to withstand extreme stress, Tesla's plane doesn't just fly, it defies all the old rules of aviation. And now that weight is no longer an issue, the question remains: is it truly safe enough to dominate the skies? The answer lies in Tesla's next step, and it involves extensive certifications, extreme testing, and an AI that never sleeps. Aviation safety is non-negotiable, and Elon Musk seems to know this better than anyone. From the project's inception, Tesla made it clear that it wasn't enough to simply create an electric plane with good range and an affordable price tag. It had to be one of the safest in the world. Therefore, the company went straight to the most critical point: FAA certifications. In 2024, the StarVolt batteries underwent a series of brutal tests required by the American agency. They withstood temperatures ranging from 58 degrees to 176 degrees, vibrations up to 12 times the force of gravity, and most surprisingly, 0 failures. Not a single short circuit, not even overheating. The result? The FAA accelerated the certification process, and Tesla is already aiming for the Part 23 certification by the third quarter of 2026. But what really impressed regulators was the battery's thermal safety. The StarVolt is 99.8% non-flammable. While most lithium-ion batteries can ignite in the event of a failure or impact, Tesla's aluminum-ion composite battery doesn't catch fire. This virtually eliminates the risk of fire on board, one of the biggest concerns in electric aviation. For even greater protection, each battery cell is encased in a Kevlar-reinforced capsule, the same material used in bulletproof vests. This gives the aircraft 50% greater impact resistance than any current electric competitor. It's protection designed for the real world, where unexpected events happen. On the physical side, Tesla applied what it learned from the Cybertruck and SpaceX rockets. The cockpit is armored with Tesla glass, a special glass produced in Texas capable of supporting 5 times the aircraft's total weight. This additional protection is important not only for external collisions, but also for withstanding the pressure of accidents or hard impacts during emergency landings. The entire cabin functions as a safety cocoon, including the seats, which were designed with 4 anchor points and rails that absorb impacts of up to 16 Gs of force, something rarely seen outside of military aircraft. And of course, the plane's brain is AI, and a good one. The same technology used in cars' FSD V12 has been adapted to predict turbulence, collisions, and hazardous situations with 85% more accuracy than the most experienced human pilots. Powered by 10 billion miles of data from Tesla vehicles, the AI learns and adapts in real time. If something goes wrong, the plane has 2 independent StarVolt battery packs and quadruple control systems. Even if 2 systems fail simultaneously, the aircraft continues operating. This level of redundancy is designed to maintain flight even in the worst possible conditions. The idea isn't to replace the pilot, it's to create an aircraft that thinks along with them. The navigation system is supported by redundant sensors, cameras, and radars integrated into the Dojo supercomputer. It detects obstacles along the way, adjusts routes in real time using data from Starlink, and even automatically avoids storms. Artificial intelligence also communicates with the passenger during emergencies, explaining what's happening and suggesting actions. It's a co-pilot who doesn't sleep, doesn't get distracted, doesn't panic, and is connected to a global database 24/7. This entire safety ecosystem was made possible thanks to a colossal $15 billion investment in test, development, and certification centers. Tesla created 5,000 new jobs in the U.S. in this area alone. The company built a veritable aviation safety city with simulations, crash tests, fire chambers, and high-altitude environments. The goal is simple: no passengers injured, even in the worst-case scenarios. To achieve this, every part of the plane communicates with the central system, from the wing to the power cable, in real time. In fact, the aircraft's electrical system is divided into independent circuits, each with its own protection against overload and overheating. If something goes wrong in one part, the others continue to operate normally. Battery management monitors each cell individually, balancing the load and monitoring the health of the structure with 2% accuracy. This prevents surprises, sudden drops in performance, or the risk of blackouts. Everything is designed to maintain stability, even under pressure. While many still question the viability of electric planes, Tesla has responded with data, testing, and an architecture so robust that even its most ardent critics are beginning to quieten. And now that safety concerns are being largely addressed, the question remains: how will this plane perform in the real world, where variables like oxygen, range, and urban mobility are put to the test? That's exactly what the next chapter will explore. And it promises to show how the Tesla plane can operate every day without drama, noise, and without needing an airport. Flying at 30,000 feet requires more than just a good battery. It requires oxygen control, thermal comfort, flight stability, and a structure that works both in the sky and on the ground, or rather, on city rooftops. Tesla knew that if it wanted to make the electric plane a viable solution for everyday use, it needed to make it functional in every detail. And that's where the pressurization system, powered directly by StarVolt, came in. Using electric compressors, the cabin is maintained at 8.55 psi, 10% above the commercial aviation standard. In practice, this means less fatigue, fewer headaches, and much more comfort during the flight. But what if something goes wrong at high altitude? Tesla thought of that too. They implemented 3 redundant oxygen generators